Recently spent some time in the city of Freiburg, a charming place in southwest Germany in the Black Forest. Now, this area of Switzerland, southern Germany, has historically had great thinkers and great professors and highly acclaimed universities. And I found out one of the world's top astrophysicists, Dr. Berdyugina, was here. She is looked at as a world expert in how the universe works and in exoplanets. She does TED Talks and is well known in astrophysics circles.
Out there in the universe. And the Earth is just one of them. In this universe, we are really tiny. We put Earth in the center of the universe. Then we realized something wrong with it, so we put the Sun in the center of the universe. Again, it was a little mixed. We put Milky Way in the center of the universe. Not so bad. And we found out in the end that there is no center of the universe. Our planet is just a single blue dot among billions of other stars and billions of other planets. We use these plants as prototypes of photosynthetic organisms in the universe. And then we build models for alien lives, how they could look. And when we puzzled with this question, how aliens can look like, we actually find answers in the backyard. When we detect life on other planets, we will understand and learn that we are not alone. And we are not special.
I wanted to interview her, but how? I thought about it and I created an alias, David Howard from Oxford University Media Society, and created some online material supporting this front. After some well thought out, tricky and delicate emails, I got the appointment, and with the backstory that I was collecting information for young students at Oxford. As I waited in the lobby of this advanced university astrophysics centre, I could see that this was a business, with funding, hierarchy, secretaries, etc. Now, before we get into the interview, for those new to the channel, know that gravity is just a theory, and my blog in 2015 explained the errors with gravity, and that it can be explained away by density and buoyancy. This blog had over 50,000 views, with not one person debunking it. Also worth knowing is that in 1931, a book called 100 Authors Against Einstein was published in German, and is in the description. This shows 100 scientists stating Einstein was leading science into pseudo-mysticism, abstraction, and speculation. It was crushed by mainstream science. Also know of the Dunning-Kruger effect, a cognitive bias in which experts mistakenly assess their cognitive ability as greater than it is. It's related to the cognitive bias of illusory superiority, and also comes from the inability of people to recognize these experts' lack of ability. Obviously, in this interview I couldn't say what I really wanted to early on, as I didn't want her to walk out. I wanted her to cover more subjects and get more answers. So take a seat and buckle up, and this gets more interesting as it continues, and presents a big key, one the truth community has needed for a while. Okay, let's play. Yeah.
Okay. And this doesn't go to unedited somewhere. You will edit this?
Yeah,
somehow?
sure. You can swear or go to the toilet or whatever, it's fine.
Okay.
Sure. Hello, Dr. Berdyugina.
Hello.
If you could just spend 1 minute or 30 seconds explaining who you are and what you've done.
Yeah, so I grown up in Russia. I fell in love with astronomy, first with physics and then with astronomy. And I realized that I want to understand the universe. I cannot live on Earth without knowing what's above my head. I just felt like I need to know. I went to the university, studied astrophysics and mathematics, a lot of programming, because when we were studying astronomy, we were told that astronomy is not just science by itself, it's very interdisciplinary. So to be an astronomer or astrophysicist, you need to know physics, mathematics, programming, and I must tell right now, lots of social skills.
Yeah, sure. Great. I've got a few questions for you, mainly going to go to teenagers. They're probably questions you don't hear often, or you probably heard when you were a lot younger. The first one I'm going to ask is, it is said that a spinning atmosphere has no border, there's no physical border between spinning atmosphere and the vacuum, and the atmosphere gets less pressured and becomes the vacuum of space. At what altitude would you say that the atmosphere stops spinning? So gravity, they say, pulls the air molecules to the Earth, but there's still some atmosphere molecules higher up.
Yes.
At what altitude would you say these atmospheric molecules stop spinning?
Well, this is, I would formulate this question that, yes, okay. So the atmosphere spinning and gravitation forces for molecules, these are two kind of different, let's say, forces, yeah? So the spinning allows molecules to escape, actually, at certain heights, yeah?
Okay.
So they can spin and escape at some point. They escape through collisions also. There's the additional forces, they collide. So
they collide with each other, or with parts
other.
of the vacuum?
With each other.
Okay.
So in order to understand when the atmosphere ends, kind of, yeah, not like having a sharp border, but what we call atmosphere below and no atmosphere above.
Yeah.
Actually, there's another term called exosphere.
Okay.
It's nothing to do with exoplanets.
Yeah.
It was terminology before exoplanets were discovered. It's called exosphere. So that part of the atmosphere which escapes. So below that part, the atmosphere, if it exists, it's called atmosphere.
And it's spinning.
And it's spinning. And colliding, molecules colliding. But above, they already, the density is so low that they can escape because they cannot collide. They don't collide anymore.
And what happens to those molecules of atmosphere that escape into the vacuum of outer space?
Oh, they go on a cosmic journey.
Okay, and they stop spinning with the Earth.
Yes, they don't belong to the Earth anymore.
Okay. Yes. Is there a set altitude, distance, where that happens?
Yes, of course. It is defined by density of the atmosphere, the gravity of the planet. But for the Earth, I have to look up. If you want me to look up, I'll look up.
No, that's fine.
I don't know that number. I know that the density falls off exponentially.
Yeah.
So I actually cannot say. I mean, we tell that the space starts approximately, let's say, at 100 kilometers, above 130 kilometers, something like this, that you can go on the orbit. I mean, this spinning means like the body spinning around the Earth means that it's orbiting Earth, yeah?
Okay.
So even if we put a satellite at 200 kilometers, it's still orbiting the Earth, even though it is not in the atmosphere. So we put satellites at thousands of kilometers above, and they're still spinning around the Earth.
They're still in low Earth orbit in this model.
They're still on the orbit. They're still spinning around.
Would they still be colliding with molecules of the atmosphere?
Yes, they will. If there are, yeah.
Okay.
At that height, yes.
Okay, great.
So everything is spinning around. All the also space junk, what we call, yeah. All this.
Yeah, I've got a question on that later.
Okay, good.
Okay.
So everything is spinning, and my terminology it's orbiting. Astronomy terminology it's really orbiting the Earth at very large distances. Moon, 400,000 kilometers, is still orbiting the Earth.
And this would also collide with escaped atmospheric molecules from the Earth?
Yes, and it also collides with the escaped molecules, and not molecules in this case, but more like particles and atoms from the sun.
Okay.
Which is called solar wind.
Okay. Yeah. Okay.
It's like hard to, I mean, the atmosphere definition is that, okay, when the molecules can escape, the atmosphere ends. You have to look up this number, for the Earth, I don't know.
But it's kind of arbitrary and it's kind of hazy.
Yeah, exactly, it's just escaping. But this escape, it's still, they can go on an orbit.
Yeah.
It doesn't mean that escape means that they cannot fall on Earth anymore, because the molecules go like this. Like they collide and they go up and down all the time, yeah? So it's like turbulence, what we call.
And the reason in mainstream astrophysics that the vacuum doesn't suck out the gas is because the gravity is holding the gas to the Earth.
Yeah, exactly.
Because everywhere else in science, when there's a vacuum and gas, it equilibrates.
Yes. If you just take without gravity, yes, then they start to mix. Yes.
Okay.
Our survey said.
On to the next question. It is written in astrophysics that the rotation of the Earth is due to, we can't feel it because of constant velocity. Now, one astrophysics guy I met, he said there are two constant speeds. Let me show you this.
Yes.
A bit like this fairground ride.
Yes.
And some people I know looked at some rotation physics, and they said if you're on the edge of this, you would be experiencing acceleration and deceleration. It's only the middle point that would experience, like the wizard in the middle. The wizard would be constant velocity, but if you're on the edge, you get acceleration and deceleration because of the two constant speeds. How would you answer that?
You mean why this happens? Or
Well, surely with the rotation of the Earth,
and
because it's going around the sun at 66,000 miles an hour, we'd be experiencing deceleration and acceleration. So think of this fairground ride. Pick one human being. So pretend that's the Earth.
So you want to include all the velocities involved, also Earth
Just two.
rotation.
The Earth rotation on its axis, 1,000 miles an hour, and 66,000 miles an hour around the sun. If you're on the edge of this sphere, like a human being, you would surely be experiencing deceleration and acceleration.
Exactly.
How does astrophysics at your level explain that?
Well, it's gravitational forces. So one gravitational force you have towards the Earth center. So this is gravity of Earth, and that what holds Earth together. And when it rotates, you experience this acceleration on the edge of the Earth and the gravity towards the Earth. But when the Earth goes around the Sun, there is gravitational force towards the center of the Sun. So two gravitational forces produce this effect of acceleration and deceleration combination.
Bingo! Yahtzee! Is that your final answer? Our survey says.
But wouldn't that mean we're not at a constant velocity, so humans should feel the rotation of the Earth?
That is interesting.
It's an interesting one. The astrophysicist I met, he did a model showing that it should show acceleration and deceleration. So I could actually show you a video where this goes around the sun, and it shows, and even you can go onto the International Space Station, which is orbiting the Earth, and this also should be showing acceleration and deceleration due to the two constant motions, just like the fairground ride.
Right. Well,
probably need some homework.
Yeah, I need some thinking.
But it's an interesting one, yeah?
It is an interesting question, yes. We usually think, that the pull, we have to compare this acceleration to the gravitational pull.
Okay.
That I would start with, because velocity is one thing, but acceleration is the other thing. So we have to compare acceleration due to rotation to the acceleration due to gravity.
Yeah.
And it's very possible that gravitational acceleration is larger. That's why we just don't feel this side.
I think we would need three different answers. One for the Earth, one for the International Space Station, and then one, imagine an astronaut outside the International Space Station. Yes. How would he be staying with the space station? Because they're all doing this they're all acting under these two constant forces, two constant motions.
Exactly, yeah.
So this is a question I can't get answered. It's a very interesting one.
Yeah, but in this case, space station and the astronaut in space, they are like we call it probe particles, free particles to probe the gravitational field. Yeah. So they will orbit the Earth because of the gravitational pull of Earth, but together with Earth, they will move around the Sun. So, and that is because the gravitational acceleration of the Earth to the Sun is much larger than gravitational acceleration of any of us to the Earth.
So they just don't notice it?
Yeah, they don't notice this.
Okay.
So that is, I think this, of course, the rotation around the Sun, orbiting around the Sun, it's a huge velocity. But we're so pulled to the Earth that this Earth to the Sun is somewhere.
Our survey said.
Yeah. In the 1700s, on the same theme, James Bradley did an experiment which was redone in 1871 by a G. Airy. Obviously, this is a long time ago. And also the Michelson-Morley experiment in 1887. All these detected no rotation of the Earth. It's a bit of a silly question.
No, they detected no ether.
No ether. Yeah, I've read this.
Yes, no motion of the Earth with respect
to the sky.
Motionless ether. That's the measurement. So they disprove that there is ether.
Okay. Yeah, this could be interpreted in many ways. So what scientific method, instrumentation or experiment would you say proves the Earth is rotating? What would be your first, number one best proof if you were doing a lecture?
That we see sunsets and sunrises,
Okay.
moonsets and moonrises, yes.
Our survey said.
This is the first, this is sky moving, basically, yeah? So.
But, obviously back in the old days, they would say the sky's moving.
Yes.
Yeah.
So, but now we know this is if we understood that we are humans, not us. Humans are not in the center of the universe, if you take this Aristotle system, we are in the center of the universe.
It's funny because the Planck probe in 2013 did say we are the center of the universe. I don't know if you ever studied that experiment.
Yes, Planck, I don't know why they said it. It's like we're in the center. Yes. That's, I want to tell this. So
sure, okay.
Aristotle said, okay, we're in the center of the universe, Earth, and everything around rotates. Yeah. Then Galileo and Copernicus and Kepler, they said, no, there is the sun in the center of the universe. Yeah. Then Hubble came 100 years ago, said that, we see that all galaxies are moving away from us. Doesn't mean that we're really in the center of the universe. Yeah. But then later we found out that space expands. Einstein said that no, the galaxy is moving fine, but it's not that because we're in the center of the universe. It's because space expands at every point of the universe. So every point of the universe could be wherever you were in the universe. You would see that everything expands from you. So you would always feel I am in the center.
Let's go on to gravity. This probably come across as a very obscure question. So these people said to me, gravity is strong enough to hold boats and cargo and cars to a spinning ball, but yet it's not strong enough to pull the butterfly down or these small areas of these dead flowers. How would you answer that?
This is the buoyancy. Yeah. So when it's the same question, how can we swim in water? So why don't you fall to the bottom of the swimming pool?
Buoyancy.
It's buoyancy.
But then couldn't gravity be explained away? Because gravity is a theory, yes? It's a worldwide agreed theory. It's not, I don't think anyone's got the graviton.
It's a theory, but it's very well tested and very well confirmed. Even though we don't see graviton, it's still very well tested. Yes.
Could gravity be explained away with density and buoyancy?
It's not gravity. I said it's buoyancy. It's combination of buoyancy and gravity.
Back to the butterfly.
Yes.
Yeah.
So you swim in a swimming pool or ship on the water. You have two forces again. So in every physics study, this for students, they need to take all forces into account, which are essential. So in this case, one goes down, gravity, and one goes up, is buoyancy. And you can swim when on the surface. When at the surface, these two forces are equal. So if you go down, gravity will be stronger, but buoyancy also will be stronger. So then you can float.
How does that affect the dead part of the flower?
It's the same. Atmosphere is the same as a swimming pool. There is atmospheric buoyancy.
Okay.
So it's the same for light creatures like butterflies and dandelion. I don't know how they call them in English.
And
how these things are called in English?
It's called a dandelion.
Yeah, the whole thing. But this one?
I don't know. There's no such word.
So they're also floating. because the buoyancy for these things is much larger than gravity. The mass is very tiny, but they are puffy. So for them, the volume is bigger than the mass. It's the mass ratio volume to mass, basically.
Okay.
So, and the volume is much bigger than the mass, and so the buoyancy is much larger than gravitation. And for the butterfly, I guess they can coordinate that.
And it would be the same answer for gravity strong enough to hold the moon in orbit,
Yes.
but astronauts can float about and pretty much choose what direction they go in.
No. Astronauts are like, for astronauts to move, again, so space, let's assume it's empty. There are photons here. We know from Planck mission there are photons, but let's say, and there are particles, but let's say in the first approximation it's empty. So there is no buoyancy there. There's only gravity in space, yeah?
Our survey said.
And move on to your subject, exoplanets. What percentage surety do you have of there being other Earth-like planets? Are you 100%, or are you 80%, or are you 65%, or do you change each week?
I think we are 100% sure that there are planets like Earth out there.
Okay.
We are, say, I don't know what's the error bar, like say 80% sure that there are 30% of those planets
Habitable.
No, Earth-like.
Yeah.
That out of all planets in the galaxy, 30% are like Earth. This is our like estimate.
Yeah.
But we're 100% sure they're there. It's just the question now in this science: how many, and how close they are to the Earth. So that is the questions. But this question, if they're there, we already solved. It's there.
Okay. With these people I was speaking to, let's pick the TRAPPIST-1 system, the one that got into the media. This was the image, and I believe with photomy and other ways of measuring, I think you measure the brightness, the electromagnetic spectrum, and spectral changes. Then this turned into this colourful planets with volcanic activity, water content. How did changes in electromagnetic activity and spectral activity and brightness, such as the image in the bottom left, how does this turn into all this information about volcanoes and water and size and atmosphere?
These are just models. All these pretty pictures of exoplanets, they are all artist impressions.
Sure.
Yeah.
Do you think that's misleading to the public?
Yes, I do. It's pretty beautiful, and if you are not in the field, like a public, you look at this, it's like, wow, this
They found this.
Yeah, they found this, and it's absolutely misleading. I disagree with this. Yes.
Do you say it's 100% these planets exist? Do you think it's a leap of faith to say, okay, I measured some electromagnetics, I measured some brightness changes, I got some spectral graphs of data. Do you think it's a leap of faith to say these are habitable Earth-like planets?
We do, well, it's still science. No, I don't think it's leap of faith completely. Yeah, so it's still science. Indeed, in astronomy, we just analyze mostly data and mostly electromagnetic. Right now, it's gravitational and particles, of course, but mostly it's electromagnetic waves. Yeah, and that light, electromagnetic waves, contain a lot of information. We learn about composition of the sun, not going there, because we analyze the light of the sun through spectroscopy, polarimetry, and so on. Yeah?
Sure.
So we do the same with stars, and we do the same with other planets. We see very little specks on our
which I've shown down here.
Yeah, exactly, on our detectors. But we can analyze this to get chemical composition, for sure, and we detect water, and we say, yes, look, there is a signature of water. We know that signature in the spectrum is water. So there is water.
How does that spectral information turn into water?
Because molecules in the atmosphere, for instance, in our atmosphere, there is molecules of water evaporating from the ocean. They specifically interact with the light coming from the sun. They absorb a certain...
So you're getting the same data?
Yeah, you get like imprint of molecular presence, because molecules are rotating and vibrating, and that requires energy for them. So for molecule to exist, it needs always absorb energy.
Okay. How can you be confident of the accuracy when you're trying to measure things 230 trillion miles away?
How what?
How can you be sure of the accuracy when you're going 232 trillion miles away with a little instrument on Earth?
Yeah, that is quite amazing, probably to understand. But this technique of spectroscopy is basically distance independent. If you see in print, of course, the problem is to collect enough photons. So when you go further away,
Light photons.
Yeah, light photons. You need to collect them enough in order to see the defect due to water absorption, what we call. And for that, for example, if defect is 10% relative to the total flux, then you need, let's say, at least 100 photons to detect it, you know? So that it depends on your detector. Let's say you need 10 photons would be probably not enough to detect it. You need more, maybe thousands of photons.
The more data, the more patterns you can
exactly.
get.
But it's really distant independent in this case. So if there is water, it doesn't matter if it's here or 1,000 kilometers or in the lab.
So what would be your number one proof? You're at a dinner party, someone says, what's your number one proof, scientific method of Earth-like planets existing in the galaxy?
So far, we know they exist through transit techniques. This is our... these are not, like you have a curve there, this is not a direct detection of a planet, it's indirect, means that the planet transits across the disk of the star and then we see this dip. This is not water, this is just a presence of a planet. And by amount, how big is this dip and how much it lasts, we can say whether it's small planet, big planet, on which orbit it is, you know. And through that we know that there are these kind of small planets, yes.
Okay, great. I have a couple of questions about the moon. I'm sure this is just an error with NASA. This is a famous image called Earthrise, but there's a problem with it because the Earth's too small. Okay, moon viewed from Earth is this size, and Earth viewed from moon should be a lot bigger.
Well, moon size also changes through month and through years. Because orbit of the
apogee, perigee.
Yes, orbit of the moon is not exactly circular.
Sure, but the Earth should still be a lot bigger than it is in that very famous image.
I didn't compare it, but we have to, I mean, in principle, one has to calculate what was exactly distance at that time of the picture, and then calculate the size of the Earth from that distance, angular, and then...
I've had some physicists do the maths on it, and they said it is a big error.
I see.
It's very interesting.
Yeah. Well, this is like to the stories. Maybe they were not there.
This is interesting. Some people I know were measuring the moon. They're interested in space and the sky. The moon was photographed at the same time in Australia and Florida. How would that be? How's that possible?
Okay.
And this can be repeated in different sides of the globe, shall we say?
Yeah. Well, they are definitely upside down, so that's...
It's rotated,
yes,
yeah.
You can, I mean, with respect to each other.
But the same phase.
Well, it's the same phase, yes. Why should it be different? Because the phase of the moon depends on the sun.
Because one of these locations shouldn't be able to see it. So on the globe, say the moon's here in Florida, the guy in Queensland shouldn't really be able to see it.
But this is a full moon, close to the full moon.
Close to full moon.
So this means that there is an angle at which it's seen. So full moon means that the Earth,
opposite.
Yeah, the moon is opposite to the sun. Yeah?
But still, with the globe, with the Earth being a globe, it shouldn't be able to see them both at the same time. And this is being repeated. This is an anomaly that some people can't work out.
If somebody does it, so it's possible. For me, it's like this, you know. You cannot say me impossible if somebody does it.
Sure.
So then I say it's possible, and then you can ask why it is possible. Then I do calculations.
Yeah.
So I would say you cannot argue. If this is not a fake news.
I can verify this.
You know, if it's not a fake news,
yeah.
then you have to say, okay, interesting, it's possible. I would like to understand why, and then maybe it's possible only a few times a year. You know, you have to.
It could be done daily.
Daily, okay.
Even
then,
with
then
just
it's,
after new moon.
Then it's fine. You know, then it means that moon is far enough from Earth that in a close to the full moon, yeah, you can see it like from the front and from the edge.
But in the model, there's a model software called Celestia.
Yeah.
Yeah, you know Celestia?
I don't know. Yeah, there are many.
It's a mod. Yeah, there's many.
Yeah,
It's a 3D
yeah.
model of the solar system. When you put this date and time in, you shouldn't be able to see the moon from both places. So there's a problem somewhere.
So probably model is wrong. I would say. This is for me, as a scientist, we're always like, okay, there's a puzzle, there's observation, which is true data, and there's a model which cannot confirm the data. Then I'm sorry, the model is wrong. So
you would say direct experience is the king.
yes, absolutely.
I agree with you. Yeah,
Absolutely.
I totally agree with you.
If this is possible, like you,
The data has to match
then the model is wrong. Then your program probably
because that's science.
Yeah, exactly. Yeah.
Okay, with the moon, it does this other strange thing. On a solar eclipse, you know where
Yes.
coincidentally the sun and moon appear the same size, which we're saying is a coincidence, yeah? The moon does a shadow on the Earth, yeah? Now this shadow is 100 miles wide.
Yeah.
This is the only phenomena in our experience here in this reality where the shade is smaller than the object casting it. So you can do a million experiments with shadows. The shadow is never smaller than the object casting it. And here we have the moon, it shrinks its shadow. The people I speak to just can't work out why this can be. It's something I can't get my head around either. Because it should be
this is
thousands of miles.
This is a parallax. Yeah, so this shadow and the toy is long way from the light. Okay, the shadow is decreasing.
No, it's not. It's always the same size. It can't go smaller than the object casting it. It says tiny shadow. This word here should really say same size shadow.
Yes, it can if you do it from the top. Then the shadow is very small.
There's another image somewhere. So think of sun and clouds. The clouds will always cast a shadow bigger or the same size as the cloud. There's no phenomena in this reality where, say my pen, can we get light? My pen, and the light comes on my pen, the shadow can never be smaller than the pen. Or my bottle. Say the sun's out today.
Yeah, but look, if the sun in the zenith and you are standing under the sun, your shadow is much smaller than you because it's from the top.
Okay, say the sun was right above my head, like the solar eclipse.
Yeah.
The shadow would not be smaller than my head. You with me?
Yeah, the cross section. Yeah.
It wouldn't go smaller than my head. So say I was 50 meters up in the sky, and the sun was right above my head, and it went on me. The shadow on the ground would be the same size or a little bit bigger. This is the only phenomena in our reality where something creates a shadow smaller. This is a problem.
I don't think it's a problem. Maybe you caught me on a spot, but I have to think about it. Yeah, some of these questions are I don't solve every day.
Sure. This is what
I have to think about it.
But this is science. This is why we question things.
Absolutely. I mean, this is I don't think this is unexplained. I'm sure it is explained. I have to think about it. Yes.
This is a quick question a friend wanted me to put in. He said, with the lunar lander, there's one rocket. How would that land with one rocket when the spacecraft is asymmetric? Like we haven't seen on Earth a craft landing. I mean, the SpaceX one they say lands, but that's very symmetrical. So it's a very asymmetric lunar lander.
Yes.
Surely we'd have seen that being tested on Earth, or we'd see things now.
It's jumping. Yes. Did you see the movie of First Man? It's called. How he practiced, I mean, in the movie, he practiced landing on this. Okay. And it was jumping like hell, like this. And he said, I will practice until I make it, so it's probably some also human skill involved in there.
Maybe a bit like when they did a manual docking with the ISS.
Yeah, it's all, I mean, this Apollo 11, it's all manual. If you go to Smithsonian, it's shocking. They use the calculator smaller than we use in our...
4 kilobytes memory.
Smaller than we have in our telephones right now. It's all manual.
Yeah, and they had when the lunar lander took off, they filmed it. You know that piece of footage? The lunar lander takes off from the moon, and they created a film. It was like a 10-second film of it taking off. And my friend asks, who filmed it and who? How did that?
They left probably cameras there. That's fine.
And then went back to get them.
No. They get through radio, pictures through radio. Yeah.
So in the 1960s, they sent videos, digital videos, back across space.
Well, it's radio. So let's say they can take pictures.
But they only had a 4K memory lunar lander, and now you're saying they had like a 20 megabyte ability to capture video. This is a strange one.
Come on, we have pictures from the missions.
But as scientists, we can't take pictures as proof, can we?
I don't know what was the technology, but in 1960s, this is 69, okay? So there were already missions to Venus, Mars, also lunar orbiters existed. They all sent pictures. Pictures from the back of the side of the moon were sent before.
I, as an independent journalist, I can't use pictures as evidence because we can watch a science fiction film, and they've got great pictures of space.
No,
you know?
no, come on. Pictures is data. Pictures is data. So, of course, you can fake pictures. In our time, 21st century is unique. We fake everything. So, I don't think in 20th... Well, of course, you can fake also all the times, or in 15th centuries as well. But if somebody... I mean, this is unethical, again, yeah? So, I mean, first approach should be like, okay, you have picture, this is data. I look at it.
Yeah.
And if I have questions, I will ask, how did you get this data? Yeah. And the person who claims that this is a data, he has to provide all the materials.
That's true.
Prove that this is real data.
That's true. And with the moon mission, they said 2 years ago they've lost all the data. You remember that? They said they've lost all the data. Because some people went to say, oh, can we study the data? Because they had some questions, like I have. And they said, oh, we've lost it all. Can't find it.
This is also, this is another force called government, okay?
Things get a little shady sometimes.
Yes. Sometimes governments want to hide things, we know this. And they can say we lost it instead of sharing them, for instance. I don't know. I looked at pictures of the lunar orbiter, for instance, of the surface of the moon, and there is clearly landing sites there. You can tell me that, oh, that picture was faked, and that's why when you look at the data, the landing site is there. You can tell it's possible, yeah, that somebody faked that. But it's also, then, of course, in this case, I can say, all right, some data faked, what can we trust here in this universe?
You would say it's healthy to trust photos and images from bodies like NASA?
Well, I mean, what can we trust then? I don't know. I mean, if we question everything,
then we end up crazy, maybe. Yeah,
we should hold on something,
Yeah.
And NASA, I think, safeguard its reputation. I would say, trying very hard. And all of us, all scientists do that. But when the government is involved, I don't know what happens. So that I can imagine that there are forces saying like, we don't want you to share this data. Sure. And then the scientists are constrained. Yeah. And then you can call it unethical from our outsider point of view. But for those people who work there, this is maybe a threat of life,
Sure.
And so it's a controversial thing.
Yeah, because NASA is a government agency.
Yes, exactly. So I don't know what they hide. I cannot prove or disprove because I'm an outsider.
Sure. Two questions about the space station. I think a year ago they had some cracked glass on the space station due to space debris. This was put all over the internet and mainstream media, but yet they still did spacewalks a week later. Would you think that's a bit dangerous to do if you're getting the screen cracked by space debris? Surely if you're an astronaut, you'd be like, hey, I'm not going out there next week because my spacesuit, I'm going to die. There's a good chance of dying.
Well, this space debris is tracked is being tracked. Not everything is known, but there are telescopes on the ground which tracking these little specks in the space and calculating their orbits. There are catalogs of this space debris, and they are like not homogeneously distributed all over. There are like packs of them, like in that, remember the movie Gravity again, like they say, oh, it's coming, you know, like this is space debris from particular mission, and it's true that they are distributed unevenly. So there are some dangerous times and there are not so dangerous.
Do you think they're just brave astronauts?
God, it's another force. You have to do things, you know, it's your job. And of course, I'm sure the government takes all possible care that people are not damaged there. But if it's a job, you just do your job.
Yeah.
You given the order, you do your job. You know, I think this is
military style. Yeah. Going on to something a bit interesting here. This is recognized all around the world as the spherical trigonometry of the curvature of the Earth, yeah? So, do you prefer kilometers or miles?
I prefer kilometers.
Okay. So, if we were to look, let's try and make this brighter. If we were to look 50 kilometers, there should be 195 meters below the curvature. It's 195 meters drop. Does that make sense? So, if I walked in a straight line 50 kilometers, I would have dropped.
Okay, because of the curvature.
Because of the curvature of the Earth. This is, how much is that? 195 meters.
Okay.
Yeah? So for 20 kilometers, there will be 31 meters drop. Okay. This has been verified through universities and astrophysicists. What if I told you I knew some people who, over 4 years, have done about 50 to 100 experiments, and they can see lighthouses and have done laser tests over between 30 and 60 miles. So like a laser hits a mirror across a long lake, like Lake Constance, near Constance, near here, and seeing things like Chicago's skyline from across Lake Michigan from 50 miles away. And they factored in the height of the person and all the maths, and that these people actually cannot find the Earth's curvature. For instance,
I didn't understand what they say.
For instance, I have a video here. I just want to show you some tests. So this guy has done some tests. Where are they going to be further on? And there's many using the P900 camera. Have you heard of this camera? It's 86 times zoom, and it's only come out recently. These people have done tests over 10 kilometers, 20 kilometers, and they can see torches, mirrors, lasers, where they've done the maths and it should be 10 meters below the curve or 20 meters below the curve. And this is getting really strange really quickly. So he's saying here, he's done the maths, I verified some of it, so this should be 21 feet below the curvature. This is only over 7.53 miles, so this is 10 kilometers, let's say. He's factored in the camera height, and there are curvature calculation tools, and he's seeing lasers and mirrors. And there are people I know, especially in America, who are doing loads of these tests, and they can't find this curvature. What would you say to these people?
They have to take into account the height at which
they
stay.
They are.
And the height of the mirrors.
They are. Even if it's 50 centimeters, they're putting that into their calculations.
How do they measure the height of their own height on the Earth? They have to know it very precisely. If they want to measure 20 feet.
Sure. What they do, they're actually generous. So say they set up a tripod at 1 meter, they actually put into the calculations 2 meters.
No, I mean height, like relative height of you, because Earth is not really round, it has bumps. That's what I mean. How do you take bumps into account?
There's an oil rig one. This one's quite far. This is like 20 kilometers.
You have to take the profile of the Earth.
So you're saying saying they're just finding a. So this is really interesting. This is 3 oil rigs, and the furthest one is 26 miles away. You shouldn't be able to see it. I mean, we can say the Earth is flat in some places and more curved in others, but these guys have done so many tests. This is 26 miles away, and the horizon's behind it. Now, they say in mainstream physics, the horizon's 12 miles away. With this new camera, the P900, they're seeing things 20, 30, 40 miles away. And this is getting pretty crazy.
I don't know. This is again like the facts you bring. I don't know what these people doing. First of all,
They're testing stuff with their eyes because they don't trust the governments. These people.
Oh, Jesus Christ! I don't want even to talk about this. I'm sorry.
Why don't you want to talk about it?
This goes crazy.
But this is science, right? You're a scientist.
No,
you're a scientist.
I don't accept this.
How can you not accept it? It's right in front of you. The oil rig's 21 miles away.
No, I don't. I want to have.
This is a test. It's a scientific test.
Who did this? Can I trust those people who published this picture?
I'm verifying these people. I know these people.
Well, okay, but this doesn't tell me anything.
Okay, how about you and I go to the lake one day and we take a P900 camera and I'll show you something really, really fucking crazy.
Well, again, there are forces in the universe, yeah? So there is atmosphere, you have to take refraction into account, you have to take geographical profile of the surface. It's not that, oh, I take a camera. You know, I have these people visiting me sometimes.
But they're not doing it, but they're doing lasers as well. You know there's lasers that cost $2,000?
I know.
And there are people who've done 25 miles, 30 kilometers tests.
I can see mountains 40 kilometers
away. Yeah, but they're high up.
Why do you claim that this is not high up?
Come on, you're smarter than this. Say you have a lake, 30 miles, water's, yeah? And you have a person here firing a laser, and you have a person here with a mirror. And
why do you claim it's on the same...
there should be curvature. With the official size of the Earth, there should be detectable curvature of about 30 meters in some cases, maybe more. And people can't find it.
There are other things to be counted. Not only just claiming, oh, there's no curvature. You have to count shape of this thing where the water is, how it feels, what's the gravity there. The
gravity there will be the same as the gravity everywhere.
Refraction of the atmosphere.
But okay, there's a test where a guy went back every day and did the same test because of different atmosphere, different atmospheric haze.
Refraction is on average always the same.
But refraction can't make a human being jump up 30 meters.
You can see light of the sun from below of horizon.
Sure. This is like refraction, I understand this, yes. But what they did in one test, he proved that it's not refraction because there was a tree above the person here and you could see the tree and everything. He said, well, where does the refraction start and stop? You know, like a mirage.
Okay, so for me, it's not science if somebody says it.
But there's tests.
We have, in science, we have a system. We don't believe everything what people say or what they measure. They are publishing results in scientific papers. There is always peer review to that. Sure. And if there are questions to the results, they have to provide all the data, all the measurements. And even if it's published, it's not, if it's just somebody published this and somebody repeats it and cannot reproduce it.
This has been repeated. I could show you 50 different people.
In which journal is published?
I could tell you for a fact that mainstream science is really not happy with these people and is shutting them down. And I could tell you another thing for a fact, that governments and government websites are also not happy.
What are you claiming?
I'm just not claiming anything. I'm here to ask questions. No, I don't have any conclusions.
That these results prove that Earth is not curved.
I'm not saying that. I'm not making any claims and I don't have any labels. What I'm saying to you is, this is strange. What do you think?
I think these measurements have to be verified by scientists. It's like claiming
but everyone's a scientist.
UFO. No, not everyone. We are trained. We are trained as scientists. We are trained with the analytical skills and scientific judgment. Even if we don't know something for sure, we can judge based on the other lots of knowledge of scientific facts.
Okay.
And not everyone can do measurement and say, look, I measured this. How do you prove it? I had one crazy person visiting me, taking pictures of dark places with the flash. And she was claiming there are these little dust particles which she sees on the flash picture. These are UFOs.
Yeah, that's crazy.
Yeah, that's crazy.
Okay,
but this is the fact.
Sure.
She took a picture of the dust particles, scattered light. But her interpretation was, these are UFOs.
But if 100 different people have done this test with this new camera, 86 times zoom, at lakes, all around the world, peer-to-peer, there's a place peer-to-peer in England, and they're getting the same results of missing curvature, that's scientific method, observable, repeatable, measurable. That's the scientific method. And you replying the word refraction isn't the scientific method.
It is? Refraction?
Well, where's your results that show refraction explains these tests away?
I can see sunlight from the behind of the horizon when the sun is down.
That doesn't mean that humans can jump up 30 meters.
What do you mean jump?
Okay, so say this human and this tree should be 30 meters below the curvature. You can't use the word refraction for them jumping up 30 meters, the tree and the person.
Why do you claim that your calculations are right? I'm not verifying right now.
I'm pretty smart. And I verified.
Fine. I have to trust you. I see you first time.
But that's what I say to you. I could send you some data for you to do some.
Thank you.
But that doesn't make you a scientist.
No. It means that I don't want to do this particular project because I'm interested in many other projects.
But you're coming to conclusions without doing tests. That's not very scientific.
I'm not making a conclusion. Any.
But as an astrophysicist, surely you'd want to look at something like that.
No.
Why not?
I'm not interested.
Why would that be?
Because I'm busy with many, much bigger questions than that.
And you think this is nonsense?
I think it's nonsense.
The detectable curvature?
Yes.
Our survey said...
What would be your first reason for this being nonsense?
Because it's proven curve is round.
Could you show me the scientific methods experiment that did that?
Oh yes, it's done in 2,000 years ago.
Which test was this? Is this the sticks in the ground one?
Sticks in ground. Ships on the horizon.
I could show you with this camera ships, they go over the curvature. I could show you them coming back.
Okay.
Reappearing.
So it works?
Huh?
So it works in your case?
What I'm saying is the human eye has a vanishing point in these tests. I'm not making any claims. I'm just trying to find things out. The human eye has a vanishing point. That's not curvature, it's the human eye's vanishing point. Ships go beyond the vanishing point and people say it's the curvature. I can prove to you today if you want, with this P900 camera, the ship comes back.
I didn't understand that.
Okay.
It's okay, fine. I'm not going to talk to people who claim that Earth is flat.
I'm trying to find answers to some very interesting things.
It's just enough for me. It's enough of nonsense. That woman was coming to me 3 times and always.
But you can't project her onto me. I'm a completely different person.
I am sorry. Do you say this picture is the data? She claimed exactly the same.
No, but this isn't a picture. This is video. This is video.
It doesn't matter. It doesn't matter.
So if I showed you 1,000 videos...
It's interpretation.
Okay, if I showed you 1,000 videos of PhD scientists doing this, these aren't a bunch of idiots, these are scientists, a lot of them are PhD scientists. If I sent you 1,000 videos from PhD scientists doing curvature tests, you would still say it's nonsense.
PhD science in what?
Many different, some are civil engineers, some are all sorts of different things. Some are astronomers.
Well, let them publish this, I want to read that paper.
But when they publish it, do you know what happens? It gets shut down. Yeah,
I want to read that paper.
No, the paper's not allowed to get out there. You even put a video on YouTube, they turn it off.
I'm not talking about this. This goes into a direction I don't want to talk about.
But this is science.
No.
Because it's measurable, repeatable, observable.
It's not science.
Why would you say that? Why would you say this isn't science when people are doing tests and capturing data?
Because of that woman I told you. There are pictures. These are data.
But as a scientist, you should say that was her and this is something different. No. You can't project an old issue onto a new issue.
No, I'll give you an example. By exclusion. Exclude that picture was, you claim that every picture is a science. It's data, I agree. This is data, somebody recorded it.
Yeah.
What comes after data is the analysis of the data.
And that's what's happening in these videos.
How the analysis is done and After the analysis, there is interpretation
Sure, and
of
that's
that
been,
analysis.
I can show you hours of this.
And
This is the data, the curvature model that every university in the world
Okay.
goes with.
Fine.
And this has
but
big problems.
Make these measurements on the moon. Make these measurements on the moon. Make these measurements on the moon.
How would we
And
get
you
to
will
the
be-
moon? They said they lost the data recently.
And you will, no, go to the moon yourself. Go to the moon yourself.
But we can't go to the moon.
Yeah, so what can I do?
But NASA said that last year they can't go to the moon because they lost all the data.
Well, sorry. We live on the planet with the water and the atmosphere and gravity and uneven shape. And if somebody measures something which doesn't fit exactly circle of the Earth, I'm sorry for this person, because this is idealistic model.
You think they just got lucky and found a flat area?
I don't know what, it's probably just whatever. It's randomness. They have to make, in order to prove that Earth is flat, they have to take million measurements at million places.
I would say there's about 500 measurements of lack of curvature that are very well done with calculations.
It's your judgment.
No, it's not my judgment. This is not my judgment. They exist. These tests exist.
They are claims.
No, they're
We say in
they're
science
tests.
claims.
They're actually tests.
These are claims. If they are not verified, these are just claims.
But you're saying they have to be verified by the scientific community?
Yes.
What if the scientific community at a high level is just shutting this information down?
Well, I can tell you. You can go and collect leaves, for instance, yeah, because it's interesting. It's biology. Yeah? You collect leaves, it's biology. You come to the biologist and you say, look, this leaf is a little different than this one. How would you explain this? And he says, well, it's just natural variations. I'm not interested in this. And you say, oh, you are a biologist and you're not interested in this interesting thing. Why this leaf is different from that? It's biology, it's science, and you're not interested.
But these aren't like different leaves. These are the same different tests of the same thing coming with the same results. That's highly scientific.
I should have asked your credentials before I talked to you. I'm sorry.
Here she demanded that I stop the recording, as she was super flustered and angry. Now, before I tell you what happened, just remember what she said earlier in the interview.
This is, for me, as a scientist, we're always like, okay, there's a puzzle, there's observation, which is true data, and there's a model which cannot confirm the data. And I'm sorry, the model is wrong. So,
you would say direct experience is the king.
Yes.
So she is a contradictory mess of a scientist. And this person is one of the world's top astrophysicists. It's laughable. And regarding the oil rig, I mean, in the words of Nathan Oakley, if you're a fundamentalist religious zealot, then that's not an oil rig at 26 miles. That would be a slightly looming non-standard refraction high in a holographic projection of an oil rig from behind the reified edge of a sphere based on an R value, turning the oil rig which seems to be there into an oil rig which is not actually there. That's what you have to assert if you are Professor Dr. Berdyugina, who is paid well to mind control young humans into thinking the same. So she then demanded that I delete the interview. So I secretly uploaded it to the cloud as I kept her talking and calmed her down. She then told me I would need written permission to publish this anywhere. I'm afraid that's not really Wayki policy, as there's a bigger picture than her theoretical pseudoscience supported on the foundations of fragile egoistic arrogance. I could say to her that anyone mind-controlling mass groups of humans knowingly or unknowingly needs written permission from Wayki, so it works both ways. I also do want to share my credentials. 50 metres swimming. That's it. As I left school at 15 because my soul knew it was all a load of garbage. And in that interview I think I'm the one that stayed rational and she's the one that got emotional and flustered and defensive. You see, it's all about the elite building and paying for gatekeeper temples and getting young people to pay to worship at them. It's a clever trick. The questions she couldn't answer are all answered in my Luminaries Mysterium documentary, where just 1 hour after I uploaded it, YouTube really shut me down and hid me from the search algorithms and removed subscribers without them knowing. My plan didn't end here though. I created double-sided flyers that are downloadable in the description and a linked Instagram account full of memes, and then bombed the city, mainly student cafes. This whole method of undercover interviews and flyers is simple for anyone to copy and paste into other cities. I've shown you how easy it is. I've shown you that the top astrophysicists are frauds. You have the tools, as they simply have no scientific method proofs. It makes it fun. The second undercover interview I did in Freiburg was on a different subject and will be online in a few weeks' time. I also have some new t-shirt designs I'll share in a moment, and as you know, I do professional true cosmology astrology / luminology with over 250 happy clients now, and I also give advice regarding the understanding and investment into crypto assets. Oh, and whoever it is who keeps getting the secret police to stop me in different countries and point guns at me for no reason before strangely letting me off, just come and have a chat and a cup of tea, mate. It comes across like you've watched too many 80s B movies and think you're all Miami Vice or something. Just need to grow up.